Let's look at the equation 3x plus 2y equals negative 6. What I want us to do here is I want us to identify the x-intercept and the y-intercept in the graph. Because what is the minimum number of points it takes to graph a line? Or to determine a line? 2. Now the reason I'm picking the x and the y-intercept is because of the particular form that this equation is in. We're going to talk more about that form here in just a moment. What do you know about every x-intercept? What do we just have in the notes? Y is 0. What do you know about every y-intercept in terms of the coordinates?
X is 0.
You already have half the answer. If y is 0, okay, if y is 0, that means you have 2 times 0. What's 2 times 0?
0.
So basically, this guy is gone, and what do you see?
3x equals negative.
Right, you see 3x equals negative 6, so it means x equals what? All right, so that fills out my ordered pair, so negative 2, 0. Look at the other thing for the y-intercept.
Wait.
For the y-intercept, x is 0, right? So what's 3 times 0? And what I see here is that 2y equals negative 6, which means y equals what? Negative 3.
So wait, you wouldn't want to solve for x or y? You just want to...
No, wait, I did solve for x, and I did solve for y once I knew what one of the coordinates was.
Okay, so, because I started off and I tried solving for x.
You solved the whole equation for...
Yeah.
Okay, we're not going to solve the whole equation for x. We're rarely going to do that. No, we may solve for y to get it in a particular form, which we're going to talk about in just a moment.
What'd you do with 3x again, sorry?
For the x-intercept, when y is 0, that guy basically goes away. And so you just have to solve what you see there, 3x equals negative 6. Divide both sides by 3 and you get negative 2. See, I'm trying to do a shortcut way instead of showing a whole lot of work. Because a lot of work would be doing this. 3x plus 2 times 0 equals negative 6. 3x plus 0 equals negative 6. See, this ends up to me being a waste of time if we can just kind of cover it up, because we know that if I plug in 0, the guy's just going to go away, right? And if you see the book will actually do this work. But I don't want to do that. I don't want to spend a lot of time just to get negative 2, when I could just cover that up. I see that x is negative 2. Cover that up, I see that the y coordinate is going to be negative 3 when x is 0.
So it will always be in the inner...
If we're trying to find...
0, 0.
For those intercepts, yes, it has to be. Otherwise, you're not actually on the x or the y axis, and you would not be intercepts. So if I plot these guys. Now, here's the thing you have to understand about plotting. Where does every x-intercept go? On the x-axis, right? Because isn't it by, that's what the definition is, right?
Yeah.
Where you cross the x-axis. So it's here at negative 2, 0. Don't plot the x-intercept on the y-axis. Likewise, when you plot the y-intercept, where does it go? It goes on the y-axis down here at negative 3. Use these points to get more points. Extrapolate. So what's the pattern from here to here? What's that slope? Down 3 to the right 2. Keep going. Down 3 to the right 2. There's another point. Down 3 to the right 2, and there's another point. I can also extend this going the other direction, right? So up 3 to the left 2. Up 3 to the left 2. Just reverse things. So basically you're taking the small little pattern that you saw here and just going to stretch it out and get the rest of the points. Now, if you're trying to graph this by hand, you don't have a straight edge, you can also find the midpoint. And that's just more points to help you plot this guy accurately. For example, look here. The midpoint is going to be half the change in the y, half the change in the x. So how far down did you go? 3, so it's half of that. 1.5. What's the change in the x?
2.
What's half of that? 1. So instead of going down 3 over 2, you can go down 1.5 and over 1. You find that midpoint by cutting in half the change in the y and the change in x, and you can get the extra points here. So 1.5, 1, 1.5, 1, and so on. So you have all these extra points, which makes it very easy to connect the dots and see that this will be a straight line. The more points you have, again, the more accurate you'll be. So what do you guys think about that graph? Do you believe I did it well? Or do you want to check it out? What, close enough?
Totally lost. I was going to talk to you about it after class if possible.
Okay. Now, if I wanted to take this guy and graph him on the graphing calculator, you would have to start with 3x plus 2y equals -6, and you'd have to do what? You have to solve it for y. Let's see if we can solve this guy for y by hand. How do you solve it for y? What do you have to do?
Move the x.
Move the x term over.
Yeah.
So subtract 3x on both sides. So 2y equals -3x plus 6. And then you have to do what?
Over 2.
It's not -6?
Oh, it is -6. I'm sorry. You guys threw me off. You made the mistake. All right, so what does y equal?
-3 over 2x.
-3 halves x. Bless you.
Thank you.
Gotta watch out for that mascara.
I
And then
know.
-3. Do y'all agree?
So the slope would be -3 over 2x. -3 over 2, right?
Should be -3 over 2. Now look at this. From this point to this point, what are you doing? You're going down 3 and over 2. So your slope, which is rise over run, is down 3 over 2. And you see the direct connection you have right there. Do y'all agree? Look at this -3. Does that -3 show up anywhere? When you're doing a problem, do we see our -3? Matches up with the y-intercept, doesn't it? Because if you look here, the y-intercept is 0, -3, which is the same as that guy right there. Now, I want to go back to the original graph that we had done by hand. Okay. Can you identify points that we graphed that were not the x and the y-intercept? Identify some points that we went through that were not the x and y-intercept.
-6 and 2.
-6, 2 is right here.
2 and -6.
All right, 2, -6. And if I look at this guy right here, this guy is -6, 6, right? If I'm saying these guys are on the line, that means I'm saying they are part of the solution set. Does that make sense? Which means they should do what?
Give you the slope.
No, they shouldn't give me. Well, if I went from point to point, that should give me the slope. But I should be able to plug them into the original equation right here. So if I take this guy right here, if I do 3, instead of writing x, what is my x?
-6.
Plus 2 times y, my y is 6. That gives me -18 plus 12, that gives me -6, which is what I was supposed to have, right?
So it's just going back and checking.
Right, because you've got these intercepts which are supposed to work. But if you pick 2 other points that we didn't have before, you check them against the original, they should work. If I use 2, -6, so that's 3 times 2 plus 2 times -6. I get 6 minus 12, which equals -6. that checks out as well. I know that my line is right. Everything checks out.